who we are. We are Kajima Corporation, established in 1840 and headquartered located in Tokyo, Japan. And our business domain is civil engineering and building construction and real estate development and design engineering. And this is a part of Kajima employees, about 20,000. And 40% of income is coming from overseas projects, including US and Southeast Asia. And then let me little bit introduce about the vision of robot implementation at Gemba. Gemba meaning a construction site in Japanese. And currently, actually we have a big pain point at the construction site, and Kajima engineer has to spend so much time to collect the data at the construction site, and it's a very time-consuming process. Engineer has to go to the job site to taking a photo and record the construction progress. That's a time-consuming process. So our vision is by deploying an autonomous robot at the construction site, and we are trying to aim to free our engineer. Will be able to allocate more time to their core task. And currently we have already deployed many robots to various types of construction sites. As you can see, from a civil engineering project to building construction project. And currently we are focusing on class 1 modeling inspection at the construction site to collect the data. And then we are trying to expand use case. As I mentioned, one brain can be applied to any robot and also can be applied to any task. So we are trying to expand use case to logistics, material transport, and manipulation, and also multi-robot operation right now. And then please take a look at the video. I want to show the punchy video to you, but
oh, do we try that way?
Sure, we have been collaborating with BuildAI for about 3 years, since 2023, and as I said, biggest pain point at this moment is to collect making a digital twin at the construction site has been so challenging for us. So, as I said, by deploying robot to construction site to collect the data. So, as you know, robot is gonna it's going to be exploring the robot to collect the data without any complaining, and so that is I think that could be a game changer for us to collect the data. And actually, I want to show the video, but actually we have been developing so many other robots. So currently, what we are thinking is we are trying to apply this general purpose robot to the robot we have built. So I think it will. It's going to be a very big impact to, and also increase the productivity of the existing robot. Yes, and yeah. So actually, we are going to work closely with BuildAI. We are trying to transform the construction industry. Yeah, thank you. I will pass it back to Ari.
I think with the combination that we have here with Ali and Hashimoto-san is that we're seeing that together you can work closely with Japanese corporates and have success here in Japan. Ali, go ahead.
Yes, sorry. I think we have a little bit of difficulty on the internet connection, but the team is trying, so I'll I'll move forward. Okay. let me
Oh,
explain.
there we go.
So Hashimoto-san was going to talk about it. I will do. I'll talk about it. Maybe don't go to slideshow. Just it's safe now. But yeah, this is basically highlighting some of our collaboration with Kojima. So scanning the digital twin creation that Hashimoto-san was talking about is very labor-intensive, slow process. Robots can help. Now we are carrying these sensors in the site, and each robot that is doing these tasks are doing actually several different tasks at the same time. Safety checks, progress monitoring, visual documentation, object cataloging, material cataloging, perimeter security, and compounding these use cases increases the ROI very quickly and justifies where these applications. As you can see, the sites are pretty complex, and we really like construction and manufacturing because these are the sectors that the data is so rich, the environment is so complex. As you train these platforms in these environments, when you move them to a new environment, let's say oil and gas refinery, let's say to perimeter security, urban operation, the robot has learned so much that transferability is very quick. Across different projects, we have done many different things. This is one of the fun things that Kojima pushed us to extremes. There was a Kodopan project, it's a big reservoir in the middle of Tokyo. The only way to get there was like robot to fly and crane it. And you can see here the separation between brain and body. The body is not operating, but the brain itself is still on and understands what's going on around itself. And as soon as legs touch the ground, brain starts operating again. And same brain across different platforms, from large vehicles to small platforms. So I'll move on a little bit. We lost a bit of time, so I'll be faster. So maybe if we can go please to the full slide. Yeah, thank you so much. So we realize these architectures across 3 layers. First layer is physical, which we learn local skills, right? So these are local skills like the ones you see here, especially now we are pushing more and more humanoids to these construction sites, from locomotion to manipulation to carrying out specific local tasks. Here you see pushing these platforms into these complex environments, carrying out operation in a setting that the environment changes every hour, every minute, because construction sites are not static, and doing a variety of different tasks at different levels of dexterity. The key here is these are also platforms that are very cost affordable, right? So you're looking at grippers that each gripper is $300, right? Each body could be 10K, 15K, and this ability to go different ranges with different capabilities, robots that are a couple $100,000, $500,000, all the way to $10,000, $2,000, it gives a lot of flexibility to the customers and to the use cases. Moving on in the interest of time, the same brain is applicable not just to humanoids, but also different types of embodiments, from 4-legged platforms to wheel platforms, that brain comes and make up for the things that hardware cannot do alone, and pushes these to the limits of the capability. This is a platform we can carry 150 pounds, like 70, 80 kilo across hours for single charge, and all the way, again, same brain handling local skills, doing a variety of different tasks. I will skip these slides in the interest of time, just to make sure we can go through all of these. But the second layer after skills is operational AI. It's one thing to keep the system stable and have local skills, but it is totally another thing to embed this into the customer workflow, have the ROI. And a key factor here is that you need to introduce solution into the customer workspace like an intern, like a new worker, meaning that we are trying to not ask customer for anything. We are not asking them to go map the environment. We are not asking them to clean up the world and give us a route to teach and repeat. There's no GPS needed. So you deploy the solution, you ask for it to carry out different operations, such as visual documentation, telepresence, such as security patrol, digital twin creation, material cataloging, and a variety of different tasks that today deployed in production. Everything we are showing here are from our customers. There's no demonstration or POC. These are all in production with different customers across the world, operating and carrying out the ROI for the customers. And this goes on even radically different vehicles like the ones you see here. Same brain, that's the key, right? Same software, same brain that learns on a humanoid, learns on a four-legged robot, sits on a big truck, big dozer. This is one of probably the highest levels of autonomy we have worked on, where the sponsor, the customer, gives us a single waypoint. They ask us to go 10, 20 miles to a point relative to a starting point. There's no GPS, no satellite imagery, no predefined trajectories, in many cases no roads. So just to highlight the maturity of these models. The models are getting better and better at a very fast pace, and we are seeing pretty exciting future as these models and different platforms are learning from each other and improving over time. So here you'll see a 55-degree slope. We actually put a human, and human in the first attempt is slid backwards. And the robot was able to show the superhuman performance in the first attempt, understanding how it changes the zigzag maneuver on the slope to handle this. Again, variety of different tasks across the board, from pushing carts to carrying bags to closing a box, and things that we are hearing from different customers, and some of them at the R&D stage, some at the production. But in the interest of time, I'll move forward here. And finally, the last layer of autonomy for us is the same brain helps the platforms to talk to each other. Because now you have heterogeneous platforms, a humanoid, a dog robot, a truck, a drone, all using the same brain, and that the benefit there is these brains speak the same language. They can coordinate. So here you're looking at an operation where 11 robots, 4 of them with legs, 4 of them with wheels, and 3 of them flying, go into unknown environments they have never seen before. No map, no GPS, no predefined trajectory, and they are discovering the world and autonomously dispatching themselves. Here, for example, you see a system facing with dust, fog. System knows I'm going to ask a robot with thermal camera, which has the right bandwidth and right wavelength to go through these particles. You see an environment that has a vertical shaft, drone takes off, maps it. You see elements with stairs, with uneven surfaces, the legged robot will. But this type of coordination happens between the robots autonomously. You as a customer provide the high-level mission, and the system understands 2 robots stands up, 10 robots stand up, and how they coordinate, how they communicate. Many of these videos we are showing here are recorded by the sponsor, not our footage. These are cameras installed by a sponsor. Only after mission is completed, we look at it and say, oh, this is where robots were at. So we just provide the software, and that carries out the operation. And today we are pushing some of these multi-agent to multi-humanoid. This is still, this one is not in production. We are still in the R&D phase on this front, but looking extremely exciting because there are a lot of complex tasks out there that you want to provide the mission, but robots need to understand themselves who does which part of the task and how they coordinate with each other. In this case, we have forced the robot closer to camera to not move, meaning there is no reach. It is not able to put the objects in the box, and has to communicate and use the other platform to help to move these platforms. So the flywheel between the model evolution and collection of data, improving the model, deploying more, collecting more data, is starting to spin faster and faster. And this is where things are getting very, very exciting now. With petabytes of data coming, these models are growing at an unprecedented rate. And more than ever, we think we are getting closer to a moment that I would not call it ChatGPT moment. I don't think that's going to happen in robotics overnight, but we're getting closer to a point that people are going to feel that the platform is doing tasks that almost reaching to a level of maybe a junior human or less trained human. With that, I will end the talk and highlight that we highlighted today tasks and verticals like construction, but it doesn't stop there. We are now deploying quite a bit in manufacturing, in perimeter security, in energy sector, and so on. And we'd love to talk to you guys if there are elements in your businesses that our technology can help. Here's our email. Please reach out, and we'd love to chat with you. Thank you, and sorry for the hiccup.
Thanks, Mali.